So today we are going to see the introduction to trigonometric ratios. For your essential question, I want you to answer the question, how do you set up trig ratios? And I'll use the word trig, short for trigonometric or trigonometry. So before we get to our vocab and our guided practice problems today, I just want to take a look at a few different triangles. So we've talked in the past about similar triangles. And we know that the side ratios or the sides of similar triangles are proportional to each other. So for this triangle here, we know that the sides 15, we have 15 over 17, and notice that we have this 72-degree angle. And we don't have this missing angle, but you'll notice that the 15 is opposite of the 72 and the 17 is the hypotenuse. Well, if we look at another triangle with that same 72-degree angle, and these are all right triangles, keep in mind, these are all right triangles. So this is 90, this is 72. That third angle is automatically going to be 18. But again, we're just concerned that we're looking at the side opposite the 72, and the hypotenuse is 34. So if we were to simplify this ratio here, that would simplify to 15 over 17, giving us the same ratio that we found in this triangle here. So again, the sides are all proportional, which means that their ratios will all be equal to each other. So if we look at this triangle here, notice we have this 53-degree angle. We don't know the measure of the third angle, but we know that we have 90 and 53. This one's 90 and 53. Therefore, the triangles are similar. So their sides are proportional. So if we were to set up a ratio, we have this side, which is considered the adjacent side. Adjacent means next to. And I know that the hypotenuse is adjacent to it as well, but we've already named that side as the hypotenuse. So the other side that touches the angle is what we refer to as the adjacent side. So if we had 3 over 5, down here, adjacent would be 12 over the hypotenuse, which would be 20. And again, this is going to simplify if we divide by 4 to 3 over 5. So again, you'll see that these ratios are equal to each other. Lastly, for this one here, we have 90, 37. The side opposite the 37 is 3, divided by the side adjacent to 37, which is 4. And if we set up that same ratio for this triangle here, the side opposite will be 27, and the side adjacent is going to be 36. If we simplify this, if we divide both of these by 9, we would end up with a ratio of 3 over 4, again, equal to the ratio we found in the previous one. So my point here is that for any triangle that has these angles, where the angles are 72, 90, and 18, the ratios of the sides opposite the 72-degree angle divided by the hypotenuse will always simplify to a ratio of 15 over 17. It does not matter how large or how small your triangle is, that ratio will always simplify to equal a ratio of 15 over 17. With this case here, the ratio of the side adjacent divided by the hypotenuse will always simplify to 3 over 5. And with this one here, the ratio of the side opposite divided by the adjacent will always simplify to 3 over 4. And this holds true for any triangle. Now, this is just 3 specific examples where we have an angle of 72, an angle of 53, and an angle of 37. But there are these consistent ratios for all triangles, for all right triangles, that allow us to set up these ratios so that we can find missing sides. Okay, and this is what trigonometry is. So let's take a look at our vocab. So first thing I just want to kind of remind you guys of is acute angle. An acute angle is an angle measuring less than 90 degrees. So in all right triangles, you will always have 2 acute angles because we have the right triangle, we have our right angle, right? That's what classifies it as a right triangle. So that's always going to be our largest angle, which means that these angles here will both be less than 90 degrees. So in all right triangles, you will always have two acute angles. The next term is trigonometry. This is the study of the relationships involving sides and angles of triangles. Please excuse my typo. So the first of our three trigonometric ratios is called the sine ratio. And if you look at your calculator, you're going to see that there is a button that has the letters S-I-N, and this is your sine button. A lot of students try to say sin, but remember that this is the sine ratio, but we can abbreviate it using S-I-N. The ratio for sine is the ratio of the side opposite of an angle to the hypotenuse. The second of our three trigonometric ratios is called the cosine ratio. Again, if you look at your calculator, you're going to see a COS button. We use that for short. COS represents the cosine ratio. And this is the ratio of the side adjacent to an angle to the hypotenuse. And lastly, the third is our tangent ratio. Again, you'll see the button TAN on your calculator. This is our tangent ratio. This is the ratio of the side opposite of an angle to the side adjacent. So I'm going to kind of put all of those ratios together. So I'm going to draw this triangle here. And whenever we talk about our trigonometric ratios, we have to have what's called a reference angle. Now, sometimes, as we've seen, your angles may be labeled as maybe A, B, or C, or X, Y, Z. Sometimes you'll be given the measure of the angle, so maybe we'll say 23 degrees here. But when the angle is missing, when we're using trigonometry, you'll often see So I want to take a look at a triangle, and I want to kind of talk about the different ratios before we move on. So here is our right triangle, and you'll often be given what's called a reference angle. So we've seen in the past our angles labeled as maybe A, B, C, or X, Y, Z, and so our angles are given a name. In some cases, we'll be given the measure of the angle, so maybe this angle is 23 degrees, but in some cases, we might not have that angle measure, and so you'll often see the letter theta, it's a Greek letter, theta, used in place of the missing angle. So I'm going to use theta as our reference angle for the sake of this example. And so what I want to do now is I want to label the different sides of the triangle. So first, we know that the side opposite of the right angle is always the hypotenuse of the triangle. And then with respect to theta, I now want to label the sides as opposite and adjacent. So the side opposite of theta is the side across from that angle. So we've been talking about that. So this side here is the side opposite of our reference angle, which is theta, the side opposite theta. And that leaves the side here, which is the side that's next to theta, but not the hypotenuse. And the side that's next to the angle that is not the hypotenuse is what we call the adjacent side. Now, if you refer back to your vocabulary, we defined the sine ratio as the ratio of the side opposite of an angle to the hypotenuse. Now, whenever you write your trigonometric ratios, whether it's sine, cosine, or tangent, it always has to be that of an angle. So if we're looking for the sine, it has to be of an angle. So the angle always has to follow that ratio, whether, again, it's the letter ABC, theta, or the measure of the angle 23. So for the sake of this example, again, we have theta here. And the sine of theta is equal to the side opposite of the angle, the side opposite of theta, divided by the hypotenuse of the triangle. So whatever the measure of those sides are is going to create that ratio, and the sine of that angle will always equal that ratio. For cosine of theta, remember it's always the sine of an angle, the cosine of the angle. The ratio of the side adjacent of an angle to the hypotenuse. And lastly, the tangent of an angle is always equal to the side opposite of the angle to the side adjacent. Now, in an effort to help you guys remember these different ratios, there is a mnemonic device that is often used to help do so. So we're going to shorten this up really quickly before we get to that mnemonic. So first, we know the sine ratio is equal to the side opposite divided by the hypotenuse. The cosine ratio is equal to the side adjacent divided by the hypotenuse, and the tangent ratio is equal to the side opposite divided by the adjacent side. And so if we just take these letters and make a word, we're going to have SOHCAHTOA. And so this is called, we refer to this as SOHCAHTOA. SOHCAHTOA. And this again is to help us remember the different ratios. So sine is equal to opposite over hypotenuse, cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So this is what I will refer back to help us write our ratios. So let's go ahead and take a look at some guided practice problems. So our first question asks for us to write all ratios for angle x. So angle x is going to be our reference angle. So we want to write the sine of angle x, the cosine of angle x, and the tangent of angle x. Again, remember, anytime you write your ratios, you have to make sure that you're taking the sine of an angle, the cosine of an angle, the tangent of an angle. And again, in this case, our angle is x. So going back to our mnemonic, we have SOHCAHTOA. So the sine ratio is equal to the side opposite of the angle to the hypotenuse of the triangle. So let's go ahead and label our sides using x as our reference angle. We know that the side opposite of the right angle is the hypotenuse. From angle x, this would be the opposite side. From angle x, this would be the adjacent side. So the sine of an angle is equal to the side opposite of an angle divided by the hypotenuse of the triangle. So that would be 15 over 25. So the sine of angle x is equal to the ratio 15 divided by 25. Now, you could simplify this. There's no need to do that. I'm simply looking to see that you are able to set up the ratio of angle x. The cosine of angle x is equal to the side adjacent divided by the hypotenuse. The side adjacent to angle x is here, that is 20. And the hypotenuse again is 25. So the cosine of angle x is equal to the ratio 20 divided by 25. Then the tangent of x is equal to the opposite side divided by the adjacent side. So using x as our reference angle, the side opposite again is 15, and the side adjacent is 20. So this is the sine of angle x, the cosine of angle x, and the tangent of angle x. All right, so for GP number 2, Using the given acute angle, so our given acute angle here is 23. Label the sides as opposite, adjacent, and hypotenuse. Then find all trigonometric ratios. So given 23 as our reference angle, the side opposite would be here, 30. The side adjacent, that is not the hypotenuse, would be this one, 72. And our hypotenuse would be here, and that is 78. Then we need to write all of the ratios for this angle. So the sine of 23 degrees, so given we have that angle, we're going to use that angle. The sine of 23 degrees is equal to the side opposite. Remember, so the side opposite, 30, divided by the hypotenuse, which is 78. The cosine of the angle, 23 degrees, is equal to, that's the cos, so cos, C-A-H, the adjacent side, divided by the hypotenuse. And lastly, the tangent of that angle, 23 degrees, that's the TOA, T-O-A, opposite over adjacent. That's going to be 30 divided by 72. Again, I'm not looking for you to simplify these ratios. That isn't necessary. I'm just looking to see that you are able to set up the correct ratios for each of your 3 trigonometric functions. All right, let's take a look at one more. I'm gonna go ahead and have you guys pause the screen or pause the video. Pause the video, give this one a go and see how you do. So in this case, our given angle is 46 degrees. The hypotenuse is the side opposite the right angle, so that's gonna be here. Remember, the hypotenuse should always be your longest side. The side opposite of 46 degrees is this side here, 21. And the side adjacent to this angle is going to be this side here, which is 20. So to write our ratios, the sine of 46, that's the SOH, sine is equal to opposite over hypotenuse. The cosine, that's CAH, so CA. CA is adjacent over H, the hypotenuse. And then the tangent of the angle, TOA, TOA, opposite over adjacent. And that is setting up trigonometric ratios. Don't forget to answer your essential question.